Okay, so we are talking about the greenhouse effect in these notes. And so let's go ahead and get into our slideshow here and get into the greenhouse effect. Okay, so here are our objectives and skills. You need to be able to identify greenhouse gases and identify the sources and potency of the different greenhouse gases. So first of all, an important thing to note, and we mentioned this in our last set of notes, is that not all incoming solar radiation reaches Earth's surface. And you can see that here in this diagram. Some of it actually bounces off the atmosphere, and some of it actually moves through. So it says about half the solar radiation is absorbed by the Earth's surface and warms it. And then the infrared radiation is emitted from the Earth's surface. So there's actually heat. When it says infrared radiation, that is actually given off as heat, and that's what we'll experience. So 26% of it is reflected back into space by the clouds and the atmosphere. 19% is absorbed by the atmosphere and the clouds, and it's radiated out into space. That heat just goes out into space. And then the rest reaches Earth's surface where it can be absorbed or reflected, depending on the albedo of the surface that it strikes. So we all know about that albedo effect, but if you aren't sure or don't remember, a darker, lower albedo surface absorbs sunlight and releases infrared radiation. Okay, and we feel that radiation, like I said, as warmth. A lighter, higher albedo surface reflects sunlight directly back into space or into clouds or the greenhouse gases that actually absorb that heat. Okay? All right, so gases in the Earth's atmosphere trap the heat from the sun and radiate it back down to Earth. Without that happening, Earth would be too cold to support life. So we actually need that greenhouse effect to occur in order to support life on the planet. It's kind of like we have to have the ozone layer in order to support life on the planet. And here's how it works. All right, so solar radiation, which are the light waves, like the UV waves and the visible light coming from the sun, strike the Earth's surface. When it strikes the Earth's surface, it heats up and it actually releases infrared radiation. The Earth's surface releases that. Greenhouse gases absorb that infrared radiation and they radiate it both into space or back towards the Earth. It just depends on where the radiation goes, where those waves move, okay? And a portion of it that comes back to Earth, the portion that does come back to Earth, is called the greenhouse effect. And so you can see here that these little arrows are showing this infrared radiation kind of hitting this molecule, and what comes back down to Earth is going to be what we call the greenhouse effect. And most important greenhouse gases that there are, so the ones that you really need to know, are CO2. All right, and so we get CO2 from fossil fuel combustion, we get it from decomposition, we get it from deforestation. When we cut down trees, there's going to be more CO2 in the atmosphere. Also from methane, CH4. All right, methane's another really important greenhouse gas, or GHG. We get methane from extracting natural gases and from burning fossil fuels. We also get methane from animal agriculture when animals break down plant material after they've eaten plant material, especially cows, sheep, grazing animals. Their body processes that and breaks down the food and then gives off methane. Anaerobic decomposition occurs with bacteria and different organisms that are decomposers, and this especially happens when permafrost thaws. A lot of methane is given off. Nitrous oxide, so those NOx that we talk about, are another important greenhouse gas. So that comes from agricultural soils by the denitrification of nitrates, and especially if crops or soils are being overwatered. Also, it is given off by over-fertilized soils and by burning fossil fuels. Another greenhouse gas are CFCs. We just talked about those, and the FCFCs and the HFCs. So all of those molecules that have chlorine, or even the hydrofluorocarbons. Okay, so those come from the refrigerants and also from the blowing agents that they use in pressurized cans. It's the stuff that the gases that cause the aerosol particles to come out. And also another important one that we just don't always think about as being a greenhouse gas is just having water vapor in the atmosphere. It acts exactly like the CO2s and all the other greenhouse gases by absorbing that infrared radiation. Okay, so, and we get H2O in the atmosphere from evaporation, obviously, that whole water cycle, and then transpiration from plants. So technically water is a greenhouse gas by definition, like I said, but it doesn't really drive up temperature change. So it doesn't cause that climate change. It actually does the opposite. It actually controls it's actually the other way around. Like the temperature of the planet actually controls the amount of atmospheric water vapor that's in the atmosphere. So the warmer it is, and then the more water that's going to be stored there. All right, so global warming potential. This is something that you should be familiar with. It's called a GWP. It's a measure of how much of a given molecule of gas can contribute to the warming of the atmosphere over a 100-year period. And the molecule that they measure this by or compare it to, it's all relative to carbon dioxide. So the GWP is based on two different factors: the residence time, or how long that molecule stays in the atmosphere, and how much infrared radiation it's absorbing. So how well does the gas not just absorb, I guess, but it also how much it radiates the IR, or the infrared radiation. So CO2 has a GWP of 1. Again, all of these gases are going to be compared to this CO2. So we give GWP, or we give CO2, a GWP score of 1. Then when we look at methane, it remains in the atmosphere around 12 years and absorbs more IR than CO2. So we give it a score of anywhere from 23 to 84. That's much higher than CO2. Nitrous oxide, the reason that we talk about nitrous oxide in this class, or nitrous oxide, is because it remains, I was getting confused. When I see chemical symbols, you guys know how I feel about chemistry. Sometimes I get confused. But it remains in the atmosphere about 115 years, and it absorbs much more IR than CO2. And it gets a score, or a GWP, of 300. And then lastly, when we look at CFCs, chlorofluorocarbons, they remain in the atmosphere anywhere from 50 to 500 years, depending on the type of CFC. And it absorbs much, 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 much more IR than CO2. So it gets a score of anywhere from 1,600 to 13,000, okay? So practice your practice FRQ for 9.3. Explain how greenhouse gases in the atmosphere contribute to the heating of Earth's climate, and identify a greenhouse gas that has a GWP that's greater than 1 or greater than carbon dioxide. Explain why this greenhouse gas has a higher GWP than 1, or why is it higher than carbon dioxide. Okay, that's it for today. Next time we're going to be talking about increases in greenhouse gases, and I'll see you guys next time.